So I have already touched on a lot of 5.2 when we did lesson 5.1 on the 3 measures of central tendency, mean, median, and mode, and how the mean, especially the mean and median, can change depending on what the data looks like, what the numbers look like. So just to sort of review that, so imagine there's 11 people in a room, and one person earns a salary of $1 million a year, the other 10 earn teacher salaries. Okay? So if you were asked to find the mean, do you think it would be higher than the teacher salaries? Yes, because of that 1 million that the one person makes. Okay? Because what happens is extremely high values will pull the mean up, extremely low values will pull the mean down. So when we call those extreme values, we call them outliers. Okay, so outliers are numbers that are widely separated from the other numbers in a set of numbers or in a data set. So like if I said 1, 5, 6, 8, 57, we would consider 57 the outlier.
Are we supposed to write that down?
Yes. And like we have already talked about, it will really affect the mean. It may affect the median, but not very much. It depends on what the data values are. Like if the data values are really all spread out from each other, then yes, it could significantly affect the median, but generally it doesn't. So just as an example, how outliers can affect things. So we want to determine the price of a house in the Charleswood area of Winnipeg. You randomly select the prices of 10 houses. Here are the prices. Okay. How would we find the mean? What would we do? Add them all together and divide by 10. So I'm not going to show all the work here, but you would go 255,900 plus 1,799,900, or sorry, 1,799,900 plus ... all the way to the end number of 331,700. Okay, and then we would divide that by 10. And when we do that, we're going to get $474,510. Okay. If we are asked to find the median, what would we do? Put them in order. So, and then how many numbers will be in the middle? 1 or 2 in this case?
Yeah.
2, right? Because there's 10 values. If there's an even number of values, there's 2 in the middle. If there's an odd number of values, there's 1 in the middle. So like if it was 9, there would only be 1 in the middle. If it's 10, it's 2 in the middle. So again, I'm not going to write all these out. Okay, so I'm just going to write the sort of important ones. So we start with the lowest. We keep listing until we get the 2 numbers in the middle. So the 2 numbers in the middle are going to be $331,700 and $364,600. And then we keep listing them until we get to the largest, which is that over $1 million home, almost $2 million, getting close to that. So we would list them lowest to highest. These are the two numbers in the middle. So the median, I would have to average these. So I have to go 331,700 plus 364,600 divide by 2, and that's going to give me a median of 348,150. Which is quite different from the mean. Okay? I mean, that's over $100,000 lower. And finally, the low. Well, if you look at those, if you look at all those house prices, you will see that none of them happen twice. Okay, so we would say there's no mode. So again, that's pretty useless to us in this case. Yes, the outlier is that 1,799,000 item. So given that outlier and given the mean and median we calculated, which would you depend on as the better measure of central tendency?
Median.
The median, right? Because that outlier, which is a high one, pulls the mean up unreasonably. Because if you look at the mean that we calculated, 474,000, and if you look at all the house prices, the mean is greater than 9 of them. That does not represent the typical. So this is really pulling it up. So yes, you would say the median. Okay? Because the mean price is too high, therefore not typical. Because of the outlier. Okay. In general, oh, shoot. Sorry about that. That should be here. Okay, so what happens if we took away the outlier? Again, I'm not going to show all the work. You should be able to do it. The mean, what we would do is we would remove that million to almost 1.8 million. We would add the remaining 9 and divide by 9. And when you add the remaining 9 and divide by 9, you get $327,244.44. The median, you would remove that $1.8 million value from listing lowest to highest. Therefore, there would only be one number in the middle. Yes. So the median would be 331, 700. Way closer to each other. Okay? So sometimes that's what we can do to address extreme values or outliers, is we can remove them and calculate what's left. There's another thing that we can do as well that I'll talk about a little bit later on. But notice when you take out those outliers, the mean drastically changes, but the median didn't change that much. Like, remember, the original median was 348. And it changed to 331. That didn't change that much. But this really came down. Okay? Oh, and so we could say mean or median. Could now be best. Because we took out that outlier and we get both of them are very close to each other. So really, it doesn't matter which one you pick. And this just kind of sums up what we did. So if there are outliers in a set of numbers or a data set, it's going to strongly affect the mean.
So wait, you said the outlier from the mean. Did you do that first before calculating it?
Yes, you take out the outlier first. Outliers on the median, it can change it a little bit. Sometimes it may not even change it at all. Okay, but it doesn't change it very much.
Do you count it when you're dividing?
No, you take out that number.
Okay.
So it would be divide 9, like with the houses.
Okay.
Yes. And then the mode, again, the mode is not the greatest measure to use. You notice I'm not really promoting the mode very much. So I'm not going to worry too much about that. Okay. So we can just look at a set of data and determine which of the 3 measures would be a good one to use. Like if you look at this set of data, well, first of all, let's address the mode. What would the mode be? 5. That seems very, very low. So again, mode, not a great indicator for us. We're usually deciding between the mean and median. Which one would you choose?
Median.
Why?
Because in 70.
Exactly. Median. Because of the high outlier. So as we already saw with one of the examples, one of the things that you can do when you're dealing with outliers is remove them. Okay. So like in that previous example with the houses, when we removed that $1.8 million home, we got a mean and median that will be much closer to each other. Here's another example of where actually outliers can occur and they are removed, is in sport, any sports event that involves judging. So for example, moguls competition, figure skating, diving, all of those involve gymnastics. All of those involve scores by a panel of judges. So let's say Jennifer in a moguls competition, these are the 5 scores she got. Okay? And we want to find her score out of 15. But notice that it says the highest and lowest scores are omitted. And then the 3 middle scores are then added for a score out of 15. So which scores would be omitted?
5.
Right. So it would be 4.2 plus 4.9 plus 4.6, which gives us 13.7 out of 15. This is a bit of a thinking one. Why do you think they do that?
One judge giving you a lower score and one judge giving you a higher score, then obviously there's something like that they can't all agree on, so the 3 middle scores are their average.
Think about it this, yes, you're right. So remember, this is a Canadian athlete. That judge that gave 5 out of 5 could very well be Canadian, right? Okay. That judge that gave 3 out of 5 from a rival country, right? Not just another country, but from somebody from a country who's also competing. So yes, exactly. Right? So it avoids bias. Yes. Avoids bias by judges. I won't write what we just discussed, but those are in notes on teams. And I mean, there's been lots of accusations of that in many years in the Olympics. Okay, and that's one way that they dealt with it. Okay. Another thing that you can do is something called the trimmed mean, which is like removing the outliers. Okay? And the trimmed mean is a percentage. And that percentage represents how much of the numbers, how much of the data are you going to remove? So that means like if you had a 25% trimmed mean, you would remove a quarter or 25% of the highest and lowest scores, the outliers. We're going to focus on 10%. Okay? So we're going to say, okay, we're going to remove 10% of the data. We're going to remove 5% from the high end, 5% from the low end. What's that? Exam. No, they don't do that for when they're calculated. They don't calculate trim mean. They'll do the entire mean. And they'll probably do the median too. Because then because what happens is, like I said, when I do test averages, I do mean and median, because if they're close together, then I feel pretty good. But if the mean is a little bit higher, that means more people got higher scores, right? So it was sort of a little bit biased towards the higher scores. If my mean was lower than my median, that means that more people didn't do as well. So it'd be like, I wonder if maybe this was, maybe I need to teach something better. Maybe there was something on the test that students didn't understand that I thought they would understand, or something like that. So just as an example of the trim mean, so we've got a manager of Manitoba Ski Hill Rental Shop, collects data on how many snowboards were rented during 20 Saturdays of winter, and there they're all listed. We want to calculate the 10% trimmed mean. So first thing we want to do is 5% below, or sorry, 5% low, 5% high. So what's 5% of 20? Remember, there's 27. So that's 0.05 times 20, 1. That means one low we're going to take out. Similarly, 5% of 20 is one high we're going to take out. Or what you could have done, you could have just done 10% of 20, get 2 and say, okay, if there's 2 of them, one high, one low. That works out to the same thing. So which ones are we going to take out?
Did you write it?
Oh yeah, there's a 32 and 156. So once we do that, and again, I'm not going to write it all out. We just take all the numbers that are left, divided by 18 because we removed 2 of them. And we get an answer of 87.3. Yeah, yeah. Yeah, you're right, because we're talking about snowboards. Okay, so obviously you can't have 0.3 of a snowboard. Okay. Well, I mean, you can have it, you just wouldn't be very effective. Okay. So a couple things you need to know from that: removing outliers or calculating the trimmed mean. Okay. So that's kind of like a fourth measure of central tendency. It's, I mean, you do it the same way you do the mean. You're just going to take some stuff out before you do the mean calculation. Okay.